You're out and about in your kitchen making your favorite cookies when ouch, the blade of your knife scrapes your hand. Not to worry though, because you know that in the next few days, your finger will be back to normal without any evidence of your accident. We take this process for granted, but there is a complex process your body undergoes to regenerate injured parts of the body. The first step in this complex process is known as hemostasis. No, not homeostasis. Hemostasis is the process in which bleeding stops and the blood is kept within a damaged blood vessel. Hemostasis may be the first step to a complex process of wound healing, but it has many steps itself. So let's take an inside look of what is going on in your body after an injury. The first step is the start of vascular spasm or vasoconstriction. Our body is filled with blood vessels like this one, and an injury would cause blood to exit the vessel. The body instinctively reacts to this blood loss by contracting the vessels. Vascular smooth muscle cells control this process of constriction, and the vascular endothelium, or lining, releases signals that control these cells. Local pain receptors also aid in starting the constriction. Overall, the constricted vessel will leak less blood and allow for the process of healing to begin. Collagen, a structural protein, attracts platelets to the area. These platelets release granules, or in other words small particles, to increase vasoconstriction, such as serotonin, ADP, and thromboxane. As you can imagine, the more damage a body is sustained, the more effective the contraction is. After all, losing a finger is quite a bit more serious than a paper cut. The next step is known as platelet plug formation. Platelets adhere to the damaged endothelium in a process known as primary hemostasis. A glycoprotein called von Willebrand factor, found in blood plasma, activates plug formation. When platelets find damaged endothelial cells, they change shape, release granules, and become sticky. Platelets have special receptors that interact with other platelets to cause aggregation and adhesion. Remember the chemicals we mentioned before? Serotonin, ADP, and thromboxane all work together to increase the platelet plug and then set a positive feedback loop to keep the process going. The final step of hemostasis is clot formation, or secondary hemostasis. Clotting factors are nearly a dozen inactive proteins found in the blood. In a series of steps known as the coagulation cascade, the inactive fibrinogen protein becomes fibrin, an important protein in clotting. A fibrin mesh forms around the clot, and red and white blood cells trapped in the mesh make the clot harden. The plug is known as a thrombus. There is a lot of research underway to take advantage of this knowledge to accelerate healing or to cure genetic disorders, such as von Willebrand disease, which affects the body's ability to create clots. Next time your cuts fade away, take a moment and appreciate the hard work your body's cells put into keeping you alive and well.